Which number? Number 5. Eigenvalues of A inverse minus 2i. First, we have to get eigenvalues of A inverse. What are eigenvalues of A inverse? For them, eigenvalues are 1 by eigenvalues of A. So 1 by 4, 1 by 5, 1 by 2, 1 by 2. Eigenvalues of A are 4, 5, 2, 2. So for A inverse, 1 by 4, 1 by 5, 1 by 2, 1 by 2. So A inverse minus 2i. It is like A minus Ki. K is nothing but 2. So for A inverse minus 2i, eigenvalues are subtract 2. Okay. 1 by 5 minus 2. 1 by 2 minus 2. 1 by 2 minus 2. So what will be this equal to? Minus 7 by 4. Minus 9 by 5. This is minus 3 by 2. Take LCM, minus 3 by 2. These are eigenvalues of A inverse minus 2i. Because what is the formula for A plus Ki, lambda plus K? A minus Ki, lambda minus K. Instead of A, we are having A inverse. So get the eigenvalue, subtract 2 from each eigen. This is A inverse minus 2i. Then eigenvalues of adjoint A are eigenvalues of, here I will take 2A transpose. So eigenvalues of adjoint A. So what are eigenvalues of adjoint A? This is number 6. So eigenvalues of A are 4, 5, 2, 2. So that A, eigenvalues of adjoint A. Adjoint A are that A by lambda. So they will be 4, 5, 2, 2 divided by 4, comma 4, 5, 2, 2 divided by 5, 4, 5, 2, 2 divided by 2, because that A is this 4 into 5 into 2 into 2 into 2 by 2. Eigenvalues of adjoint are that A by lambda. That A means product of eigenvalues, 4 into 5 into 2 into 2. These are eigenvalues. So that A is nothing but product of eigenvalues, 4 into 5 into 2 into 2. So simplify this. What will you get? This is nothing but this is nothing but equal to 4, 4 cancels, 20, 5, 5 cancels, 16, 2, 2 cancels, 40, 2, 2 cancels, 40. So these are eigenvalues of adjoint. Next, eigenvalues of 2A transpose. We are asked to find. Number 7. Eigenvalues of 2A transpose. So first we have to get, it is like Ka. First we have to get eigenvalues of A transpose. So for A, eigenvalues of 4, 5, 2, 2 implies for A transpose also eigenvalues are same. A and A transpose have same eigenvalues but different eigenvectors. A inverse and A and all others are having different eigenvalues but eigenvectors are same. So what are eigenvalues? Which are nothing but 4, 5, 2, 2. Because A and A transpose have same eigenvalues. Now you want 2A. So eigenvalues of 2A transpose. For this, eigenvalues are multiply each and every element by 2. Because for Ka, eigenvalue is K lambda. 2 into 4, 2 into 5, 2 into 2, 2 into 2. These are eigenvalues of 2A transpose. So we have completed all the shortcuts, whatever we have seen till now. Okay. So if A is in upper triangular form or lower triangular form or diagonal form or shortcuts, all ones or all case, we know how to find eigenvalues and eigenvectors. But suppose it is an unknown matrix, it is not upper triangular, it is not in any one of the previous forms, then no shortcut works. Then how do we find out the eigenvalues? So that we are going to see. So method 2 of finding eigenvalues. Method 1 we have seen till now. What is eigenvalue means? Ax is equal to lambda x for some non-zero column vectors. Then x is what is called eigenvector. Lambda is what is called as the eigenvalue. So Ax equal to lambda x. If you can find out a non-zero column vector x satisfying this, x lambda is called eigenvalue, x is called eigenvector. Method 2. This is not possible, always not possible to find all eigenvalues. You know, number of eigenvalues of A equal to order of the matrix. If A is n by n, there exist n eigenvalues. So method 2 of finding eigenvalues. So we use eigenvalues are nothing but roots of the characteristic equation. So eigenvalues are roots of, they're also called characteristic roots, proper values, characteristic roots are roots of characteristic equation. It is also called secular equation, characteristic equation. Determinant A minus lambda is equal to 6. This equation is called characteristic equation. Roots of this equation are called eigenvalues. And determinant A minus lambda I or determinant A minus xi is also called as characteristic polynomial. Characteristic polynomial. This polynomial, when you equate it to 0, you get an equation that is called characteristic equation, CE. So now, if you find out the characteristic equation and solve it, you get roots, they are called eigenvalues. So find eigenvalues of the following. First one, 5, 4, 1, 2. Number 2, 0, 1, 1, 0. Number 3, 0, 0, I minus I. Number 4, 0, 0, 1 minus. Three by 3. How to solve? You are given one question. Imaginary parts of the eigenvalues are the largest eigenvalue is. There is no shortcut here, so we will have to work out this. Largest eigenvalue. Eigenvalue of the matrix is. We have to find. Okay. So one more here. Imaginary parts of the eigenvalues are. We'll take up this 3, 2, 5. This we'll try to copy so that we can answer this bit as well as that. Okay. So I'll try to select this. Only matrix. I want only matrix. So this matrix also we will take up. Let us find out for all of them what are the eigenvalues. So here I will copy. This is a matrix for which you will get even complex eigenvalues. So I want to do this question 3 by 3, particularly when no shortcut works, how to find them. Okay. So let us see how to solve it. First one, there are no shortcut works here. It's not upper triangular, not lower triangular, anything. It's like this. And one more I want to do. 0, I 0. Let us see. First one. So first A is equal to 5, 4, 1, 2. I'm showing original method. I'll try to show you how to come from the options. That method also we will try to solve. First, let us go for this. What is the characteristic equation? CE is determinant A minus lambda equal to 0. All of you know this methodology. So what is A minus lambda means? This is nothing but 5, 4, 1, 2 lambda into I. Because this is 2 by 2, we consider 2 by 2 identity matrix. 3 by 3, take 3 by 3 identity. 5, 4, 1, 2 minus lambda 0, 0 lambda. From next time, don't do like this. This is first problem, so I'm doing. So what is the characteristic equation? Determinant of 5 minus lambda, 4 minus 0, 1 minus 0. This is 2 minus determinant of this matrix, which is nothing but this. So directly from next time, whenever you want characteristic equation, don't do all this. Subtract lambda from the diagonal elements. Directly you get the characteristic equation. Next problem onwards, we will do that. Don't do all this. 5 minus lambda, 2 minus lambda, remaining 2 as it is. This is in the form AD minus BC. So 5 minus lambda into 2 minus lambda minus 4 is 0. This is nothing but 5 into 2, this is 10 minus 5 lambda minus 2 lambda plus lambda square minus 4, 0. Just multiply. This is lambda square minus 7 lambda plus 6, 0. So if I factorize this, luckily it is factorizable. If it is not factorizable, apply your 9th class method, minus b plus r minus root of b square minus 4ac by 2a. But here it is factorizable. So lambda is equal to 1, 6 are eigenvalues. This is how we find out. But if it is given for MCQs, don't do like this. This is original method. What is method 2? Coming from the option. Eigenvalues of 5, 4, 1, 2 are. For example, you are given this. So this much space will not be there for you. So options will be given to you. So this is options. C option 2, 3. Suppose you are given this. Then, or you are not given this, none. Skip it. None of this. Then, how do we do it? Coming from the option is the best one. Because what is the relation? Sum of eigenvalues should be equal to trace. So, given any question, to find out the trace, what is it by trace? Sum of the principal diagonal elements, 5 plus 2, which is 7. Sum of eigenvalues is nothing but trace A. So, find out trace A. Trace A means sum of the principal diagonal elements. For any given question, find trace A. Then product of eigenvalues must be tet A. What is the determinant of this matrix? AD minus BC, 10 minus 4, that is 6. So, given any question, find out these two. Then go to options. If at all they are the eigenvalues, if you add, you should get back trace. When you multiply, you should get back det. Both should be satisfied. Whichever satisfies both, that is your answer. Most of the students, intelligent students, what they will think is, this is 4 plus 3, 7. So sum of eigenvalues is nothing but equal to trace. Satisfied or not? Yes, satisfied. So they will answer first option as the right option. Intelligent students, when you add, you are getting trace. So immediately they will jump and conclude. The so-called intelligent. So be careful. Product should be 6, sir. 4 plus 3 is 7, correct? 4 into 3 is 12, which is not equal to det. If at all they are the eigenvalues, their sum should be equal to 7, their product should be equal to 12. It is not satisfying. Product should be equal to 6 here. Determinant, but it is not satisfying. So this cannot be the option. Next. 0 plus 7, 7, very happy again. But 0 into 7 is 0, not 6. When you multiply them, product of eigenvalue should be 6. We are getting 0. Sum is satisfying, but second is not satisfying. So this is. Next, 2 plus 3, 5, not satisfied. This cannot be the right option. Some students, they will think 2 into 3, 6 satisfying, but the first one is not satisfied. So this cannot be the eigen. So what is the answer? None of these is the answer. What are the eigenvalues? 1, 6. Because 1 plus 6 is 7. 1 into 6 is 6. When you add them, you should get back trace. When you multiply them, you should get back the product. Okay. So we get this, some of that. Second question. What is the second question? 0, 1, 1, 0. It is not diagonal matrix. Diagonal matrix means principal diagonal should be 6. This is which type of matrix? Can you tell me? Any one of you, could you cognize? We have seen types of matrices. Symmetric, skew symmetric, Hermitian, skew Hermitian, like that.
Skew symmetric, ma'am.
Is it skew symmetric?
No, ma'am.
It is which type of symmetric? Correct. This is symmetric. Why it is symmetric matrix? Because principal diagonal can be anything. These two should be equal. If they are opposite sign, same value, then skew symmetric.
Skew symmetric.
So this is symmetric. Now, how to find eigenvalues? Determinant A minus lambda equal to C. So that means subtract minus lambda 1, 1 minus lambda equal to C, which implies lambda square minus 1 is C, which implies lambda is equal to root 1 plus or minus. These are the eigenvalues. AD minus BC. This is the one. So, what are the eigenvalues of this matrix? 1, comma, minus 1 are eigenvalue. Some students, what they do is, they think this is diagonal. And they will think 1, 1 are the eigenvalues. But this is not diagonal matrix. This is symmetric matrix. Diagonal means these two should not be 0, these two should be 0. This is opposite. So 1 and minus 1 are the eigenvalues. Be careful. This is not diagonal matrix. Third one. 0i minus I 0. 0i. I'll take up one more. 2 star. 0, 1. Minus 1, 0. For this, what are the eigenvalues? This is which type of matrix?
Skew symmetric.
This is skew symmetric. Skew symmetric. Let us find eigenvalues. Characteristic equation is determinant A minus lambda is equal to 0. Subtract lambda from the diagonal elements, minus 1 minus lambda 0, which implies lambda square plus 1 is 0. So lambda square is minus 1. Lambda is root minus 1, plus or minus sign. So the matrix is real matrix. This is a real matrix, but eigenvalues are complex. So very important note is, if the matrix is real, can you say eigenvalues will be real all the time? No. This matrix is real, eigenvalues are also real. But whereas this matrix is real, but its eigenvalues are purely imaginary. Purely imaginary means no real part. This is a skew symmetric matrix. So two things we will infer here. What are the two important things? Eigenvalues of, very important, eigenvalues of real matrix need not be real. Need not be real means sometimes they may be complex also. Sometimes real, sometimes complex. Need not be real. Generally, what is the intuitive feeling we are having? Real matrix means eigenvalue should be real like that, but which is not so. So eigenvalues of real matrix need not be real. They can be complex. Example is above. They may be complex. Some are eigenvalues. Example, A is equal to 0, 1, minus 1, 0. This is real. Eigenvalues are real matrix with complex eigenvalues. And eigenvalues are complex. So sometimes they may be real, but not necessarily. Or I minus I, which are complex. Complex eigenvalues. And moreover, it is a skew symmetric matrix. So very important is the eigenvalues. Very important. The eigenvalues of real symmetric matrix, real symmetric matrix will be are real, are always real. The eigenvalues of skew symmetric matrix, the eigenvalues of skew symmetric matrix, real skew symmetric. If it is imaginary, we can complex, we cannot say. Real skew symmetric. Either 0 or purely imaginary. Very important. Purely imaginary means 1i, 2i, 3i, like that. They will be either 0 or purely imaginary. Here we got them as purely imaginary, I minus I. Purely imaginary means IB form, where B is not 0. 1i, 2i, 3i, like that. They will be either 0 or purely imaginary. Very important. And eigenvalues of real matrix need not be real. These are the three inferences we have seen. Now, next. What is the next matrix we are having? This is 0i minus I 0. Third one. 0i minus I 0. Which type of matrix? Any one of you could you cognize?
Skew
It's a
symmetric matrix.
It is skew symmetric, correct? Not only that, it is complex skew symmetric. It is complex skew symmetric. One more. It is also, is it symmetric? No.
No.
Any one of you could you cognize? What is this? Skew Hermitian,
Skew
Hermitian, like
Hermitian.
any one of you?
Admission.
Hermitian, correct, good. Why it is Hermitian? What is Hermitian matrix characteristics? Principal diagonal must be purely real, need not be 0, purely real. These two should be conjugates of each other. What is in the conjugate? If you replace I by minus I, you should get back this. So this is skew symmetric. This is also Hermitian. So let us find out eigenvalues. Determinant of A minus lambda is 0. This is characteristic equation, which implies determinant subtract lambda. AD minus BC. Lambda square plus I square is 0. AD minus BC. Lambda square minus 1 is 0. Lambda is root 1 plus or minus. So what are eigenvalues? Eigenvalues of A are minus 1 comma 1. These are eigen. Okay. Now, eigenvalues of A are 1 minus 1. This matrix is complex. Matrix is complex, but eigenvalues are real. Whereas previously matrix real, but eigenvalues are complex. So here matrix is real, but eigenvalues are, for this matrix, eigenvalues are complex. This is real. Real matrix, complex eigenvalues. Complex matrix, but eigenvalues are real. So complex matrix need not have complex eigenvalues only. It may have real eigenvalues also. So very important note is eigenvalues of complex matrix. Complex matrix need not be complex. Not necessarily complex. They may be real also. That is, may be real. So for example, here, this is a complex matrix, but eigenvalues are real. For example, so you may get yes or no, like which of the following are true or false. A complex matrix will have complex eigenvalues only. Real matrix eigenvalues are always real. Like this, options will be given to you. So need not be. For this matrix is complex matrix with real eigenvalues. But eigenvalues are real. Eigenvalues are real. 1 minus 1, 1. So this is Hermitian. So very interesting point is, see, I have given earlier, eigenvalues of skew symmetric matrix are either 0 or purely imaginary. This is only for real skew symmetric. This is complex skew symmetric. So this is not satisfying this property. 0 or purely imaginary, not satisfied. Because it is complex skew symmetric. If it is real skew symmetric only, this holds true. Very important. Next one. This is eigenvalues of Hermitian matrix. Hermitian matrix are always real. Not only for this. Hermitian matrix are always real. Very important. Next one. We have next question. This is which one? 0, 1, minus 1, 0 already we have done. 0, I, 0. Sixth one. This 2 star is nothing but 4. This question is already given. This is nothing but question number 4. Question number 5 is 0, I, 0. Question number 5. So A is equal to 0, I, 0. This is which type of matrix? Can you identify?
Symmetric and skew Hermitian. Symmetric is skew Hermitian.
It is symmetric, correct? Complex symmetric. Symmetric and skew Hermitian. What is skew Hermitian matrix? Principal diagonal must be either 0 or purely imaginary. Off diagonal should satisfy Aij is minus Aj bar. That is conjugate minus of the conjugate. What is the conjugate of I is minus I. Minus I is plus I. So for this is I, this is minus I bar. That is minus I, which is plus. So they will satisfy this property. So it is skew Hermitian. So what is the characteristic equation? Determinant A minus lambda equal to 0. Determinant minus lambda I minus. Lambda square minus I square is 0. What is I square is minus 1. So lambda square plus 1 is 0. Lambda square is root minus 1. Root minus 1 is plus or minus I. So what are the eigenvalues for this? Eigenvalues are I and minus. This is symmetric. but eigenvalues are not real. So if it is real symmetric only, if it is real symmetric only, eigenvalues will be real. If it is complex symmetric, eigenvalues need not be real. This is one of the best examples. I and minus I. And one more thing, this is Q Hermitian. So, very important. Eigenvalues of skew Hermitian. For Hermitian, they are always real. Skew Hermitian are either 0 or purely imaginary. They are either 0 or purely imaginary. Very important. Next one. Eigenvalues of idempotent matrix. Try to remember them because contest has come. I am giving here. Idempotent matrix are either 0 or 1. Eigenvalues of nilpotent matrix. Nilpotent matrix of index k, whatever may be index, are always 0. All eigenvalues of nilpotent are 0. All eigenvalues of 0 matrix are also 0. Because eigenvalues are 0, you cannot say matrix is 0. Because for nilpotent matrix also, all eigenvalues are zeros. So all eigenvalues are zeros. Then which of the following is true? A must be 0 matrix. Like that, options will be given, which is not correct. Eigenvalues of nilpotent matrix are all 0. Whatever may be the index, you will be given k eigenvalues 0, n minus k eigenvalues 0, all eigenvalues 0 like that. So very important is all eigenvalues of nilpotent matrix, whatever may be the index, are always 0. Next one. Eigenvalues of orthogonal matrix. What is orthogonal matrix?
A into A transpose equal to
A into A transpose equal to I, which is A transpose into A. Eigenvalues of orthogonal matrix are such that mod lambda must be 1. That is, all eigenvalues magnitude should be 1. Some intelligent students will write mod lambda 1 means lambda equal to plus or minus 1, which need not be true. So lambda may be plus or minus 1, or it could be like this also. This is nothing but what is modulus of complex number? Root of a square plus b square, positive square. When you square and add, you will get 1 by root 2 square. B is 1 by root 2, I coefficient. 1 by 2 plus 1 by 2, which is root 1, which is 1. Positive square. So, eigenvalues of orthogonal matrix are such that mod lambda equal to 1. Always. That is, magnitude should be 1. If it is real, it will be either 1 or minus 1. So what are the possibilities? Lambda may be 1, minus 1, or it could be like this, etc. It can be 1 by root 2 minus 1 by root 2. 1 by 4 plus I into root 3 by 2. 1 by 2 plus I into root 3 by 2. Like that, it could be anything. Its modulus should be 1. That is the only requirement. Next one. Eigenvalues of what is that matrix? A into A power theta equal to A power theta into A is equal to I. Then what is A called? Any one of you, do you remember?
Unitary matrix.
Unitary
Unitary.
matrix. Eigenvalues of unitary matrix. Such that mod lambda is 1. For this also same condition. Mod lambda 1 does not mean lambda equal to 1 and minus 1 only. Lambda may be 1, lambda may be minus 1, or lambda may be any complex number whose magnitude is 1. So, these are the things which you have to remember. Now come back to our question. It's not yet over. We are having some more questions here. Yeah, this question. 3, 2, 5, 2 minus 3, 6, 0, 0, minus 3. 3, 2, 5. Here, wait. What is that question? 3, 2. Question. Remember this question. Note down somewhere. This is 3, 2, 5. Note down somewhere. 3, 2, 5. 2 minus 3, 6, 0, 0, minus 3. 3, 2, 5. 2 minus 3, 6. 0, 0. Minus 3 is it?
Minus 3.
Minus 3. This is the one. This is not upper triangular. Because this is not 0. This is not lower triangular. This is not diagonal. But we are asked to find. So, characteristic equation. Which implies determinant 3, 2, 5. 2 minus 3 is, is it 6 or minus 6? There in the question. Minus lambda into 1, 0, 0, 0, 1, 0, 0, 0, 1. Because this is 3 by 3, we are taking identity as 3 by 3. So, determinant 3 minus lambda, 2, 5, 2 minus 3 minus lambda minus 6, 0, 0, minus 3 minus. This is the characteristic equation. We have to expand the determinant. So, it is easy to expand along last one because many zeros are there. Plus, minus, plus, minus, plus. So, what will be the determinant for this? 0 into anything 0, minus 0 into anything 0, minus 3 minus lambda into determinant 3 minus lambda 2. Amma.
Second row, third element only 6. Not minus 6.
Minus 6, plus 6. Plus 6. So, this is anyway, it is not affecting our value 0. This into 3 minus lambda into minus 3 minus lambda minus 4 is AD minus BC. So, remaining will be zeros. 3 minus lambda minus of 3 minus 3 minus lambda minus 4 C. So, this is the characteristic equation. We have to solve it. So, minus 3 minus lambda 0 or here. When you expand, this will be minus common 3 minus lambda into 3 plus lambda minus 4C. This is A square minus B square. So, this will be 9 minus lambda square minus of 9 minus lambda square minus 4C. Minus 9 plus lambda square minus 4C. Anything wrong? Any mistake anywhere? So, this will be minus 9 plus lambda square minus. So, this is lambda square minus 13 is C. Plus or minus 2. So, lambda is equal to minus 3 plus or minus root 30. These are the eigenvalues. Any mistake anywhere, Satish? Any mistake? Are you finding any mistake? Amma?
No mistake, ma'am.
No mistake. Okay. These are the eigenvalues. So, eigenvalues of this matrix are we could find out using this methodology. Okay. Next. Any question left? No. This is how we solve using characteristic equation. Next, for this question P, we're asked to answer something. Here. The eigenvalues, the imaginary parts of the eigenvalues of the matrix are, I have taken 3, 2, 5, 2, minus 3, 6, 0, 0, minus 3. Did I take correctly? What is the characteristic equation for this? 3 minus lambda. Is this the question we have done? 2 minus 3 minus lambda, 6, 0, 0, minus 3 minus. So this is nothing but 3 minus lambda. We have seen, if I expand the determinant, this will be 0 into anything 0, 0 into anything 0. This is minus 3 minus lambda. 3 minus lambda into minus 3 minus lambda, minus 4, 0. I think same we have solved. We got eigenvalues as minus 3. What are eigenvalues here?
Plus and minus root 13.
The imaginary parts of the eigenvalues are. The question itself is incorrect somewhere. Because we should get complex eigenvalues to get imaginary parts. What are the imaginary parts? Okay, let it. What are the imaginary parts of the eigenvalues are?
0.
This is 0.
No imaginary part.
0. No imaginary part at all. What is imaginary part means? I coefficient. So is there any imaginary part? No. So 0. Is there any imaginary part? No. So 0, 0. So there is no imaginary part. Imaginary part means I coefficient. It is 0 because they are purely real. Purely real means eigenvalue, that is eigenvalues will be, imaginary part will be 0. So 0, 0, 0, A is the right answer. So what are the imaginary parts of the eigenvalues is 0. Because all are purely real, imaginary parts are 0. Next. Which of the following is an eigenvalue of A? This is given to us. So when you add them row wise, sum of the rows 2 plus 1, 3, here 4, here 3, not equal. Sum of the columns is also not equal. So we cannot apply shortcut. Then which of the following can be the eigenvalue? We will have to find out. No other alternative. What is the characteristic equation for this? Determinant A minus lambda is 0.
Given as homework in the previous, we got
Yeah,
the
previous. Given. Which of
And
the
A is
following is
correct.
eigenvalue?
first option A correct. 2
A
plus-
correct. How did you get that directly?
Already we calculated.
We
You
calculated.
calculated. Okay, you
Hmm.
calculated. Okay, good. So you have done homework. So 2 plus root 2 is an eigenvalue. What is the other eigenvalue? You might have got 2 minus root 2 also.
Yes.
Because it is real matrix. If one eigenvalue is 2 plus root 2, the other eigenvalue will be 2 minus root 2. One more eigenvalue will be, sum of the eigenvalue should be equal to trace. So when you add them, you should get back trace. What is trace here is 6. So one eigenvalue is 2 plus root 2. The other is conjugate third. This also will be an eigenvalue. Lambda 0, 6. So what is the eigenvalue? 4 plus lambda is equal to 6.
Two.
Lambda is 2. So what are the eigenvalues of this matrix? 2 plus root 2, 2 minus root 2 and lambda equal to 2. These are the eigenvalues. Because whenever A plus root B is an eigenvalue, A minus root B also will be an eigenvalue. So be careful. Next. Largest eigenvalue is, no shortcut is working here. So what is trace of the matrix? When you add them,
7.
you are getting 7. What is determinant of the matrix? That we need to calculate. So how to solve this is, we have to, because 3 eigenvalues are there, we cannot solve from the options. better is that is solve it. What is the determinant characteristic equation? Will you solve this? What is determinant? You want me to do or you will solve it? Characteristic equation. -2, -3 minus lambda, -4. 3, 5, 7 minus. Find the character. Plus, minus, plus. This is 3 minus lambda. Can you calculate? Emma, shall I leave it as homework? Find the eigenvalues, whichever is
Okay, ma'am.
greatest
We'll
among
do,
them
ma'am.
is the. You do it.
Okay.
You complete this, get the eigenvalues, then which is greatest out of them, that is your largest eigen. Okay, please do it as homework. Next one. Let us go for next concept. Some interesting results about, this is the story about eigenvalues, finding eigenvalues and eigenvectors. Then what we observe is, some eigenvalues for some matrices, they are repeating. Some are different. So, it has given rise to a concept called algebraic multiplicity. Algebraic multiplicity.